Sorry for that. But I'll give just a quick minute for everyone to get back, get situated. Hopefully, I saw a lot of you were going to grab a coffee, which was very appropriate. And we'll move into the next case. So yeah, I'll just give everyone a quick minute and get your case open. We're going to be doing the intro to EDA Analytical. So let me also share my screen and get situated. And get my Slack back. Okay. Yes, I know it wasn't a full 15 minutes. I'm sorry about that. Oh, I realized I said 11:15. I'm sorry about that. That's completely I forgot about your time change, but hopefully that was all clarified and no one left for an hour. My time zone right now is 11:15. I also want to say all of you, thank you so much for showing up at 8 a.m. your time on a Saturday. That's very admirable. So yes, sorry about that. I will try to remember that. I think you are an hour behind. So let's go ahead and dive into this case. If you are, kind of getting back in, getting situated, getting seated, that's okay. I'm just going to give an introduction. So, take your time. I know you didn't get that full 15 minutes. I will try to keep us on track. So yes, and try to remember the time zone change so I don't tell everyone that you have a very, very long break. So this case is going to be focused on actually using Airbnb data. So we're going to continue with our process of EDA, but our last case was very, it was an analytical case. It was more thinking about the data, things like that. This is going to be much more detailed in terms of the actual graphs that we would make. And we will, in the next part of the lecture, go into the actual code to make some of these visualizations. So this is going to be more detailed on the process of exploratory data analysis. So let's see. So making sure everyone is back. Oh, some questions about subtitles. Yes. Okay. Okay. So yeah, so we're going to be talking about this Airbnb data, and our business, our kind of business context for this is that Airbnb is basically a bunch of small businesses all together, so kind of combined into one larger umbrella of Airbnb, because each person is renting out their home or apartment. There also are larger businesses, sometimes hotels will rent on Airbnb. And we want to know, so because this is a bunch of small businesses together, it can be difficult to optimize prices. It can be difficult to figure out trends because it's a lot of sub businesses in one. So our goal, our kind of goal for today, is to figure out what features are most relevant to the price of an Airbnb listing. So we're going to be looking at a particular data set and trying to help Airbnb figure out what are the most important features, what features are most relevant to the price. So we're going to do some, we're focusing on New York City as the data set. So obviously Airbnb is worldwide, but we are going to focus our analysis on New York City. Just for the sake of not having an overwhelming data set. This will help us to look at kind of a specific area, and some of the details we'll explore there. So we're going to do some initial plotting to just look at the distribution of our data. We're going to learn about we're going to do some correlations today. And we're going to look at, we talked in our previous case a lot about confounding variables or interaction effects, and we're going to continue with a little bit of that today as well. And so we will first look at our data set. So the first thing that we're going to do is explore some of those features. So our data set has it has 30,000 rows. So like I said, we're doing this for the sake of size. This is just our New York City data set, and it already has 30,000 rows. We have 81 columns. And so we're just looking at some details of our most important columns, like neighborhood, location, so longitude and latitude, the property type, what is it? How many bathrooms, how many bedrooms, the price of the listing, how many reviews the location has, and parking. And it's, we'll notice later in our data set, we'll work with this in a bit, but some of these are indicated by like a 1 means there is parking, a -1 means there's no parking. So, it's always important to inspect your data set ahead of time and look at some of these features. And that's what we're going to do here, and look at some summary data for these. So, the first thing that we want to do is look at the distributions of some key quantities of interest. So, it's important to kind of see our distributions, looking at some of those summary statistics, like the mean, the minimum value, maximum value, and these quartiles. So I'm hoping that you have already covered this in a previous lecture, so you know what the 75th percentile means, the 50th percentile, things like that. Is that correct? Can someone just say like a yes or no? Yes. Okay. So hopefully that has been covered in the past, and you kind of know what the mean is, what the minimum, maximum values are, things like that. All good. Okay, perfect. So looking at these things, we can look at some key variables like the price. Knowing the average price is important. Knowing that maximum price, this is a good place where you can find things like outliers, things that look odd in your data, let's say. And it might be kind of hard to find those outliers from something like this with price. Even if we had a value that was 5,000 instead of 500, we don't necessarily know that's an outlier. You could absolutely have an Airbnb that's $5,000 a night. You couldn't immediately rule that out, but in some cases you could find outliers just looking at the summary data. And then we're also going to look at some of these percentiles, the 99th, 95th, and 90th percentile. So, for this, again, for some of these things that we think might be important, like price, bedrooms, bathrooms, just to know kind of the distribution of our data, to know, what is those top values in terms of price. We already knew our maximum, but knowing look at this big difference between our 90th percentile and our 99th, right? That's a pretty big jump for 10% there. So let's think about exercise 1, as we just talked about some of this data. So we have looked at just some of these summary statistics in terms of the mean, in terms of, count is just, how many values there are. So we've looked at some of this. And then another way that we can look at our data is through a histogram. A histogram shows kind of our distribution as well, the layout. So these graphs also these plots also tell us a bit about our distribution of data. Like I said, you can see that there's a pretty big jump here. Majority of our data, 90% of our data, is $250 or below for price. The same with, bedrooms. So you can see, a pretty good idea from just this, what our data looks like in terms of these couple of variables that we find important. And then we can also look at a histogram for these. So let's think about exercise 1. What are the basic shapes of these distributions? Normal, skewed, multimodal, for these histograms. Are they fairly smooth, or do they exhibit spiky or discontinuous behavior? And where might that come from if it is kind of discontinuous? So let's look at our price histogram. We have our bedrooms histogram, our bathrooms, and number of reviews. So just a refresher, I think, so people are putting in answers already. Awesome. So that leads me to believe you also are pretty familiar with histograms and that how this shows the distribution of your data, what right skewed versus left skewed means. And if anyone is unclear, just pop that in the live chat, and I'm happy to take a couple of minutes to discuss, skew and what histogram is in terms of, I think everyone understands about binning, that this just shows you how many values are in this range. 0 to 50, we have about almost 4,000, a little less here. Okay, so a lot of answers are that it is skewed, that looks like it's right skewed. Okay, so, and no one has said that they are feeling confused about histograms. So that's awesome. I think you would have covered that in your visualizations lecture at least. So yeah, so we're looking here at price, which is right skewed. We can tell because we have this kind of tail coming off here. Our tail is on the right. We have the most of our values clustered here at the lower end of price. Most of our data is there. For bedrooms and for bathrooms, it's really hard to kind of identify them as skewed per se. You could say that they're a little bit right skewed, but since most of our data is really clustered around particular values, it's a little bit hard to say that they are skewed. So you can also see here the same thing. So yeah, it looks like everyone had a pretty good understanding of what this is. So, one of the answers here says that price is a bit spiky. So you can kind of see that there's this spike here. It's not like a clean, but I would still say, this is right skewed. But let's say, can we think of a reason why price might look like this? Like, why does it have this little bit of spikiness here? And hopefully this is pretty straightforward. We can look at our values. And I can also go ahead and show the answer since we're discussing. Okay. Yeah, so, it's just showing there are some, there are less values here at this $0 to $50. Most of our locations in New York are going to be here. And, it is it makes this trend clustering between like $50, let's say, and closer to 250 is where most of our values, maybe even 300, most of our values cluster. So hopefully this is pretty easy to interpret in terms of, where most of our data falls. So, okay. So we're looking, down here at the bottom of my screen. So can you detect any outliers from these histograms? If so, do they suggest data error or data that should be omitted from our future analysis? And let me scroll back up. We're looking for outliers in these histograms. Yes, a good point about looking at box plots, which is a great predictor. We will do that next. So people are saying not really. It doesn't really seem like there are any obvious outliers right off the bat. And I would agree with that. Like I said before, we don't see anything super out of the ordinary. Even, you might suggest that maybe some of these are outliers in terms of price. They are on that upper end of price here, and there aren't that many values, but I would not automatically assume that's an outlier. Like we said, even if you have higher numbers, it doesn't mean that it's wrong. It could be an outlier because the norm of your data is around, this value. So seeing something at 500 or even higher, 6 or 7 might be kind of an outlier in terms of the data that you have, but doesn't necessarily mean it's wrong. And this is something that's important. Let's go down to 1.2. So yeah, this kind of summary for the answer is, you might think of them as outliers, but I would not eliminate these from the data, right? You should, and it doesn't necessarily suggest data error. So all of these look pretty legitimate in terms of reasonable numbers. And if no one has told you this before, you should be very hesitant to cut out any data, unless you know for sure that it is wrong, or that you're missing values, or there's been some error. It can really affect your data analysis and further outcomes if at the beginning you're cutting out data. So you should always be hesitant about that. And always be, the biggest thing for EDA is to always document what you do. So if you ever remove data, if you ever change data, modify it, very important to make note of that and to report it with your analysis. Transparency is the biggest thing with data analysis, and data manipulation can be very can drastically affect your outcome. So you have to be very careful about any steps that you take to modify your data. So in this case, I don't think that we should cut out that data unless we were explicitly told to cut out any higher price range listings. So let's talk about this. If you have your case open, you can try to see if you can run this for exercise 2. So this is just talking about, we're going to be talking a bit about a density plot today, if you haven't seen that already. So just a difference between density plots and histograms. So this is kind of a cool app that can show you the differences in terms of, a density plot when you change a density plot bandwidth. How does that change? So what we're looking at in red is our density plot outline and then our histogram underneath it. So changing our bin width, will make, we have more bins. We can see a little bit more clarity in our data in terms of the different spikes in it, how our data divides up, and then we can adjust our bandwidth. And that just smooths out our density plot to either show us just a general trend of where most of our data falls, which in this case, is here, or if you had a lower bandwidth, it can make it really spiky. And so it's important to, excuse me, find the what is most accurate in terms of, you don't want to over smooth your data, but you also don't want to do something where you have it kind of like this, where it's overly spiky. You do want to find, based off of how much data you have and where those points come out to be, that you can kind of match your density plot to go with your histogram. So basically the point of this is that a density plot is like a smoother version of a histogram. And that's kind of what we'll be talking about, some of these plots that we're going to show. So you can play with this a little bit to smooth your histogram a bit more, and also to figure out how a density plot is also related here to your histogram width. So it wouldn't really make sense if you have clear divisions in terms of price, right? If you're charging like $100, $150, $200, it's not going to make sense to bin things for, let's say, increments of 25, right? It would make more sense to bin things for increments of 100, 150, 200, things like that, if that's what your data comes out to be. So, in Python, you've probably seen this if you've made histograms, it will automatically do it for you. It will guess at what you think at what the correct bins should be, but you can always change that if you know more about your data. If you're having trouble with the app, that's okay. You can kind of look here for now, and we won't spend a huge amount of time. It's just to say that, as you increase your bandwidth, you're going to smooth out your plot. And as you increase your histogram bin width, you're also going to make it, your bin width is going to make it each bin bigger, and you're actually going to end up doing the opposite. So playing with this a little bit in terms of making your data more spiky, less spiky, getting an overall trend. So hopefully that kind of makes sense, knowing what you know about histograms in terms of making the bins bigger or smaller. So let's also think about, someone mentioned wanting to see some box plots. So if we also, instead of making a histogram, we look at box plots in relationship to price. So let's say that, we have these variables of interest. Um, so one thing that we might be interested in is, when we are initially looking for trends, it might be, when we're looking for these trends in our data, we've picked out some variables of interest to first inspect for our EDA. We have picked, we thought price was interesting, bedrooms, bathrooms, numbers of reviews. So what you can do for your EDA is to start with picking a couple variables of interest and comparing them. So what we're looking at here is that we have created some box plots for what is the relationship between price and bedrooms. So also, if anyone is unfamiliar with box plots, just let me know. I'm happy to kind of go over that a little bit, but just a brief refresher. When you're looking at a box plot, we have our median as the line here. And then we have our 25th percentile and our 75th percentile. And then we have this upper bound and lower bound. And so that anything outside of those would be considered outliers. So that's kind of how we're looking at this data. So, I guess one of the main things that you really look at is oh yeah, it looks like it was covered in your last lectures. Perfect. So it's just a brief refresher. Is we're going to look here kind of at the median, looking at trends and also how variable each thing is. So we have price versus bedrooms. Then we have number of bathrooms versus price, or price versus bathrooms. And yeah, so someone asked about the meaning of this part of the plot. So these are points that are considered outliers. So we calculate this kind of upper bound and lower bound based off of the interquartile range. And then any points in our data that are outside of those bounds that we've calculated would be considered outliers for our data. So these are data points that kind of exceed, we would consider those outliers. So we're also looking at our price versus number of reviews, like the number of reviews that each location has received, and the price versus review scores cleanliness. So kind of how clean that place is. So those would be some things we can look at. How does price relate to any of these? So let's go ahead and comment on that for exercise 3. Comment on the relationship between price and the variables in the above plots. So do you notice any trends? What do you think that price would be related to here, if anything? I'll scroll slowly and let me know how we're doing in terms of speaking speed. Is everyone okay with that? And is everyone understanding what we're doing so far? Okay, so some people are saying price is related to bedrooms. There seems to be this positive relationship. Okay, it's okay. Okay, good. Anyone just let me know if you need me to slow down. I know I get off track and lose myself in thoughts and start speaking really quickly. Okay, and some questions about these outliers. So, oh, it looks like people in the live chat have answered some of those. So the whiskers are calculated. You take 1.5 times your interquartile range, and that's how you calculate these. So these whiskers are based off of your interquartile range. So you would take 1.5 times your interquartile range and then add it or subtract it from your 75th and 25th percentiles. Okay, good answers here. So good observations for trends. So it seems to be that price versus bedrooms, the median price seems to increase as we increase the number of bedrooms. That kind of makes sense, right? Same for bathrooms. We see this general increasing trend here. For 4, we get a little bit odd in terms of the median here, and our distribution goes, it's very variable. So for the most part, we see this trend. For number of reviews, we don't really see a trend that holds pretty constant, I think. And the same for cleanliness. We don't really, maybe a general slight increase in terms of median, but a lot of outliers here, especially for this data. So, so hopefully that makes sense in terms of what we can kind of see from these initial relationships. So from there, we noticed that we have this positive relationship between price and bedrooms. So, from that initial looking at some of those variables in comparison to price, and I want to say one of the reasons that we chose price is always to remember what our main goal was for this exploratory data analysis, which was to look at how price or what factors are most related to price to help Airbnb determine what the price should be for specific things. So our job is to look at what variables are most related to price. So that's why up here we made these box plots of price versus a bunch of other things, is we are most interested in what's related to price, okay? So we're looking at correlations. So we had found this it suggests a positive relationship in price versus bedrooms for our box plots. So what if we wanted to know if that is a correlation? So basically what that means is that there is a relationship between them. And again, tell me if you've already learned about correlations and I'm just repeating myself here, but with a correlation, that means that there is a general relationship between two variables. It does not mean that one variable causes another. You may have heard correlation does not equal causation. And so that just means that because we see a relationship between two variables, we'll look at correlation, we will get a number that signifies the strength of the relationship between two variables, but it doesn't necessarily mean, in this case, like let's say that we find a positive correlation, which means that as the number of bedrooms increases, so does the price. If we found a strong positive correlation, that does not mean that it's causative. It just means that there is a relationship between them, okay? So that there is this potential that they affect each other, that they have a relationship. But as we'll also talk about in this case, that it's not necessarily causation. There can be other variables that influence these as well. And so the strength, there's a good comment about, does that include, the 8 and 11? And so you'll see that your data affects the strength of your correlation. So let's talk about that. So when you have, what we have here is when we run a correlation, we will get a value between -1 and 1. So a correlation of 1 is, incredibly rare. You shouldn't ever really get a correlation of 1 unless you were comparing price to price. But a positive correlation means that as one variable is increasing, so is another, kind of like what we see here. And that number, so if you have between 0 and 0.25, that's a pretty weak correlation. It's a weak positive correlation. The same with, usually in data science, we would say that you must be above 0.5. In this case, we'll see that won't really be what we go off of, but kind of the standard, it really depends on your data set, but most commonly accepted is that if you were at 0.5 and above, you're at a pretty strong positive correlation. Especially if you're between 0.75 and 1, that is a particularly strong correlation. 0.5 to 0.75, still a strong correlation. And then below there, you're getting into kind of a weak positive correlation, and the same holds in the opposite direction. So, and I think someone just posted in the live chat a really good explanation for this. Yes, what it is: moderate, strong, weak. So thank you very much. That's super helpful to everyone. And so for a negative correlation, that means that as one thing increases, the other decreases. So that would be, for example, if we saw the number of bedrooms increasing, but we saw the price decreasing. So basically the opposite. If we saw that 1-bedrooms were super, super expensive, and we saw that 7-bedrooms were really cheap. So if we saw the opposite, that would be a negative correlation. And then I'll go back to someone's point about the 8-bedroom thing. So when we see, so this would generally, we would imagine, be a positive correlation. As one increases, so is the other. But because we have some of these things that, these other data points that don't necessarily hold on that trend, that will lower our R value for the correlation. That will make it, it will likely still be an overall positive correlation, but it will probably be a lower number because we don't have an exactly perfect positive correlation trend here. And some of these other data points, like you can see, we have some outlier points. Those will kind of skew our correlation a little bit to make it not quite a super high number there. And we'll see that when we look at the values. And someone asked about different types of correlations in the chat. In Python, you can choose the different type of correlations. A Pearson, a Spearman. In this case, where it's I believe it is automatically a Pearson correlation when we put in our code. We'll go over the code in the next section. But anyway, so the important point here is to just think about these R values in terms of what they mean for your correlation. And we'll look at some examples. So it's, we are going to compare first our, price. That's what we care the most about, right? We're really interested in what things are related to price. So if we generate some correlation numbers, some R values, this is called a correlation matrix, because we are comparing this thing to everything else in our data set. We can get all of the pairwise correlations here. And so let's look at these numbers. Because we have some positive, but this would probably be, like basically no relationship. It's almost zero, right? Which makes sense. Host ID and relationship to price, you wouldn't really think that there's a relationship necessarily between the ID number and the price. And then, we can look down here and look for some things that maybe stand out. Accommodates has a pretty high 0.57 correlation. That's a pretty strong positive correlation. Again, I wouldn't say a super strong, like someone posted, it's a good idea to use things above 0.75, but we'll go anything 0.5 and above we'll say that's a strong correlation. And we see this 1 here for price, always good to check it's compared with price. So that makes sense why it's a 1. So yeah, this is showing all 81 of our columns compared to price and showing the correlation for them. So now, this is a lot to look through, right? So we just want to look at, we can sort through and look for the things that are most positively or negatively correlated with price. So we can filter out some of this data and just look at the things that have the most positively and negatively correlated. I want to pause and just say, does anyone have any questions or confusion about correlations and what the numbers mean? And a good question about how can we interpret the relationship with categorical variables. So yeah, basically what that means is, does having parking, like for example, parking or no parking, does that correlate with your price? So is it that, for a categorical variable, that a higher price correlates with yes parking, or does a higher price correlate with no parking? So with categorical variables, it's a little bit more difficult, to do those correlations because it is a binary, a yes or no, but we're looking for a general trend in terms of, do these places that have higher parking, or excuse me, higher prices, do they generally have parking or no? Okay, so we are looking at, so we've also divided this into the variables that are positively correlated here and separated it from the ones that are negatively correlated. So in this case, we don't see a ton of really strong positive or negatives. And so that's what I said before about it's also dependent on your data set. So, in this case, we don't see anything that is above 0.57. And that's okay. We're not going to throw away this data set and say it doesn't work, nothing is super highly correlated. We will continue to look for those trends. What this means, though, is that when you find some initial things that seem to be positively correlated, you should absolutely mark that to investigate further. That when you see something that is maybe has a general positive trend, there could be other, but not super highly correlated in terms of a really high R value. That's also an indicator to look for those confounding variables or interaction factors, that there could be other things that are more responsible for influencing that relationship that you see. Anyway, so let's move on to exercise 4 here. So from the tables above, which factors are most correlated with price, either positive or negative? Which correlations are surprising, and what do you hypothesize might explain them? So that's a couple of things to answer here. Which ones are most correlated with price, either positive or negative? Which ones seem surprising to you? And what do you hypothesize might explain them? And good question about removing outliers. So you don't need to remove outliers to calculate correlations. In fact, that could, absolutely skew your correlation to give you kind of a false positive or false negative strong correlation. The outliers in your data, as long as they are legitimate data points, should, they will tell you how, whether the relationship is linear. And I guess that's something that I should go back and explain a little bit. What this is looking for here is it a linear relationship? Meaning, as we look here, do we see that direct, as one increases, the other increases, almost making a line, a positive, a linear relationship. So, just because we don't see a high correlation number, it doesn't mean that there's no relationship. It may just also mean that not just that there are other influencing factors, it's just not necessarily a linear relationship. So, let's discuss let's go back to our question and talk about our positive correlations here. So a strong one is our bedrooms. And of course, the number of people it accommodates, that kind of goes along with bedrooms, right? So that makes sense to be a positive correlation. Someone mentioned that they're surprised it wasn't a stronger correlation. And I would agree, you would think that as the number of bedrooms increases, so does the price. But if we go back up here, like I said before, you can have these other values, some outlier values. We see a lot for one bedrooms that can skew your correlation. Having such a broad range here in terms of your values for a 1-bedroom rental, it seems to be kind of messing with our correlation a little bit, but that's okay. We still see a pretty strong positive relationship here. And then, for price, this is kind of interesting, right? This is kind of a standout. Longitude with price seems to be a slightly negative correlation. So maybe this hints at location being something that maybe we should look into. Longitude is really vague. We aren't necessarily sure what the relationship will be here, but we should explore it further. Something else that seems kind of odd is maybe parking, right? someone else in the live chat had mentioned parking before. So this number kind of implies no relationship between parking and price. And if anything, like a tiny bit of a negative relationship, but this is a very close number to 0. So, but that seems kind of odd, doesn't it? Parking should be, you would think that price would increase if there's availability of parking. So this is also when it's important to come back to what we talked about in our previous case, which is that it's important to think about your data, right? To not just go with your correlation numbers and say, okay, I'm only going to look at the things that were the most positively correlated and throw everything else away. There are things that might stick out in your data and you might say, I expected a relationship with parking. Someone made a good point in the live chat, it's New York. So yeah, thinking about the location you're in New York, you might expect that there could be reasons for this, location is very important in New York. It's a city, parking's hard to find, things like that. But we had still expected some kind of relationship maybe. So you can still pick out, even if we don't notice a trend right off the bat, we can still pick things out of our data to explore in more detail the relationship. So that is what we're going to do. So, there were a couple of things, I guess, I didn't mention. One of the things that was mentioned, the answer is a superhost. You would think that maybe that also correlates with price, but it doesn't really seem to. There doesn't really seem to be a relationship. But these are just things that, if you have data for them, they are things you could choose to continue to look at. So yeah, we're going to look at that parking relationship, and we're going to look at, that location. So let's go ahead. Let me check any questions so far. Okay, good comments about these observations. So let's look at location. And remember, we will do the code for this next. So don't worry, we're just going to kind of look at the output for now and think about our thought process for each of these things and how we can analyze our data. So one thing was that we noticed location, right? We had that longitude variable that seemed to be kind of correlated, but that strikes us as kind of odd that it would be that way. But it kind of hinted to us maybe we should look at location and how that relates to price. And logically, that makes sense to us, right? That where you are makes a difference to how much you're paying. That should be hopefully something that, when you're going through your data, you think, yeah, that's an interesting trend I would like to continue looking at. Okay, so one thing that we can do is make a heat map of the price of apartments or rentals in New York City. And this will give us a sense of where important locations are. So this is our heat map that we've made. And so this gives us a hint as to, kind of where we're seeing higher prices. So, this will be helpful in terms of, actually getting a really cool visualization that can show that distribution for where you are and price. So let's think about this now. If you have your own notebook open and are following along, that's great. You can kind of scroll through this. What areas of New York City have expensive rentals? So we have this heat map. You can navigate through. You have you can zoom in, you can zoom out. You can kind of click and move. Let me zoom out a little bit, and I will also move it around on my screen. And you may not, I understand navigating these maps might be a little bit difficult if you've never been to New York. I am not from New York, so I also looked around and tried to figure out those important points of interest here, but we just want to know kind of a general location of where are, and that's what makes the heat map great. It kind of color codes it for you so you can figure out those locations of interest, even if you have never been to New York City before. So we can move around on this map and see our data points. And you can also, if you just want to kind of indicate, yeah, really good answers. Okay, so this seems to be that most people are understanding kind of what we're looking at here in terms of what this heat map is looking at. We are looking at price in different regions of New York for our data. So we see that Manhattan and Brooklyn are pretty pricey. And then as you get farther away, it gets cheaper. So, you know, that's kind of here and Brooklyn. And then as you move away, you know, we can see that things, as you move out farther, here's Brooklyn. As you get out farther, you can see that things kind of get cheaper on the perimeter. So the takeaway from this is that these heat maps can be really great visualizations for showing trends in your data and helping you. It's really hard to look at just a sheet of data and try to find a trend, but this can also help us a little bit. So into what we noticed before with our correlation between longitude and price, right? We were a little bit suspicious there. What does that mean? So looking at this map, you can roughly see the correlation between price and location, that kind of longitude. Does location appear to be strongly related to price? Does it seem likely that this relationship would be well summarized by the correlation? So let's take a minute in the live chat. Looking at that map, does location appear to be related to price? And is it summarized by a correlation? Looking at the correlation between location and price, did that do a good job of summarizing this relationship? Okay. So some people are saying it doesn't seem to be super well summarized. Other people are saying by a correlation. Other people are saying yes, that you can see the relationship. Okay, yeah, location impacts price, but longitude is not a variable. Yeah, okay, great observations here. So you are correct that location does appear to be related to price. As we can see, we can see this because we are showing on this map price, and we see these clusters, these kind of hot spots, and locations where you have higher prices, clusters of higher prices depending on location. So we would say that yes, there is a relationship, but it's not really linear, right? It's not that as you move east, you have a higher price, or as you move west, you have a higher price. It seems to be based off of, you know, whether you're in Brooklyn or Manhattan or Queens. It's the neighborhood, not just whether you're moving north or south or east or west. So it's not a linear relationship. So our correlation gave us a hint that, yeah, maybe we should be looking at location. But that's also why we only saw, I think it was longitude that was correlated, but not latitude. You know, so that gave us a hint, hey, we should look at location, but that we don't really see a linear relationship here. This seems to be a relationship that's more based off of, you know, price is related to location, but not necessarily a linear relationship. So it's not really summarized by a correlation well. Okay, so does that make sense to everyone? We're now going to discuss our next variable, which was parking, right? We thought there should have been a relationship there or something, and there seemed to be kind of nothing going on with parking and price. I'm just checking in on the live chat. Okay, so yeah, this makes sense. Okay. Oh, and a good point about how in some places, yeah, that's a good point that in some places the prices in North versus South would be related, and so you might have a stronger correlation there in a city where if it's more expensive to live in the south part of the city versus the north part of the city, you would see that relationship. So, moving into parking. So, this is going to be a good example of talking about these interaction effects or confounding variables. So, we've looked at some factors that affect price, and we found something kind of unexpected in terms of our relationship with price and parking. So, this is going to be something that's really important in your own data analysis for your own projects and for in the future when you're doing your data analysis in your jobs or wherever it may be. And that is that just because you don't see a trend right off the bat when you start your analysis, it doesn't mean that there's no pattern. It just means that if you think, that there should be something there, or you're curious to know more, right? If your hypothesis for this was parking would be positively correlated with price, and you see this, it's always a good idea to continue digging. The whole point of EDA, of exploratory data analysis, is to probe your data in as many ways as possible. So it's really to try to find any trends that exist in your data. That's why it's called exploratory data analysis. You are looking at your data from every angle, and you're trying to find particular trends that stand out, things of interest. So we right now are only looking at our data on its face, a very superficial analysis, very introductory. So we're looking at, just the basic price column compared to parking. We looked at it for the correlation. Is there a positive relationship? Not really, but we haven't actually started to dig into this yet. So the first thing that we have here is for all of our data points, we've made a density plot. And we talked about how a density plot is kind of like a histogram. It's just a smoothed out histogram. So here what we see in our density plot is that most of our data clusters around this price, which we saw before. That made sense. Most of our price for our data sets were between this, it was like $50, I think, and $300. So this is just plotting out the price of the listings and then whether or not they have parking or not. So the parking cloud or plot is in green and no parking is in red. So you can think of this kind of like, this is just like a histogram. It's just smoothed out. So what we're looking at here, and we can, I guess, kind of see now our relationship, that negative 0.019 relationship, because we see that parking and no parking follow kind of similar patterns. When we look at our data as a whole, there doesn't really seem to be a relationship. If there was a strong relationship for our whole data, we might see a big parking, like hump for parking for green might be over here, our peak of our data, and no parking might be here. That could indicate a pretty strong relationship. But because we see they follow pretty similar trends, then our number also makes sense for correlation, having that no relationship. But what we want to do now is we want to investigate this a bit further. So we want to find, this hidden variable, something that might be actually influencing this more that we just haven't seen because we aren't looking at our data in a very granular way quite yet. We're looking at the whole data set for New York as a whole. So, that's also what this statement makes here, that you should really look at your domain experience. Think about your data, use your own knowledge to question, why might it be this way? Why are we seeing this? What else could I do to my data to probe this a little bit more? Okay. And also good points in the live chat about you don't want to torture your data long enough just to make it tell you something. If you probe it too long, and that is something you'll get into with statistics, that you want to explore your data, but you don't want to artificially create trends that aren't there. And that is a whole issue for another time. But for now, you do want to continue with looking at this beyond, the whole data set level. So let's do that. So what we can do here is we know, we saw in our previous heat map, looking at price, that it seems to be location based, right? Price and location seem to be corresponding. So that means that we might also want to look at parking in terms of location specific. We might want to break it down into neighborhoods. So maybe, that it is really location here that's very important. It's that hidden variable. So what we can do is we can make correlations for price and parking for each neighborhood. Does that make sense? So we'll also go over the code for that, but we would break it down by each neighborhood and say, okay, what's the correlation between price and parking just for this neighborhood and just for this other neighborhood, for each neighborhood in New York, to see if this is something that is neighborhood specific. And so here's our resulting histogram. So we have made, we've calculated correlation values for price and parking for each neighborhood, and then we make a histogram to show this distribution. So actually, do you remember our original correlation number for parking was basically 0 or a negative 0.02. But actually, when we see where most of our data points fall, it is between this 0 and 0.5. We see that actually, based off of this histogram, there's kind of a positive relationship. Now, this shouldn't confuse you. This is not in terms of like number of data points. This is for each neighborhood. So more neighborhoods fall in this positive correlation. So this can be kind of tricky because we'd have to think about why. So in our next exercise, so actually this is our next question. So that's perfect. So why, explain the relationship between the histogram and our finding that parking is negatively correlated with price. So let's think about why we see this histogram and why our overall correlation number is basically 0 or slightly negative. Why do you think that is? And there's a good question about how do you separate neighborhood into levels. So, you would get this from your data set where they would have location data for that rental, where it would say what neighborhood is it in. So that would be how you would define it in this case, that it would give you that data. You could also divide it maybe by zip code. It just depends on where you are. In this case, we saw that maybe location is important. So that's a good question, how you're defining, how you're breaking down your data to be more granular. And in this case, we have that neighborhood data. We know which listing is in which neighborhood. So we're breaking it up that way. And so, yeah, why do you think that overall, when we plot all of our rental data points for New York, we see this no relationship, slightly negative, but when we break it down by neighborhoods, it seems like more neighborhoods actually have a positive correlation with parking, which means again that as price increases, so does parking, meaning that as price goes up, there is parking, which is tricky because this is a yes or no, but the positive just suggests that yes, as price is increasing, that means that there's parking. So yeah, so really great answers. So what we want to say here, or what we want to think about is actually, overall, the reason that we see that overall trend is that there might be more listings. There might be more listings here in these neighborhoods where it is kind of negatively correlated. So it's all about the number of listings. Here, we're just breaking down this histogram into the number of neighborhoods, right? So when we see this frequency, here we see that there are I guess, about 90 neighborhoods that have positive correlation. And here we see that there are approximately 40 neighborhoods that have this slightly negative correlation. So this histogram is looking at the number of neighborhoods, but there could be a lot of listings in these negatively correlated neighborhoods, which kind of skews our data set. And that's why we didn't see that overall positive correlation that we expected to see, because more data points fall in these neighborhoods that are negatively correlated. But when we break it down into neighborhood level, which we will do here, we can pick out the neighborhoods that have that positive or negative relationship in terms of their parking. So let me just go back up here to exercise 6, just to clarify that answer, to make sure that that makes sense to everyone. That it's, when we're looking at all listings, that's how we get that 0 number for correlation. But when we break it up into independent neighborhoods, then we can see that there are actually more neighborhoods that have a positive correlation. But when you look at overall listings, there may not be that many listings in these neighborhoods. Does this make sense to everyone in terms of why we see this trend? And just let me know if you have any questions about this trend. So the next thing that we did want to do is, like I said, this was just a histogram of all the neighborhoods together. But if we pick out individual neighborhoods, here we're looking at St. George neighborhood, Greenwood Heights, Brooklyn Navy Yard, Rego Park. So if we look at these density plots for parking, which, another good point is that we should have a legend again, but we don't see that here. But anyway, green is parking, red is no parking. So, we can see a difference now where it doesn't necessarily follow that same. When we looked at all of the listings in the density plot, we saw that they matched pretty well. And here we can see some differences. We can see these plots kind of diverging a bit from, from each other. So, then we could look at the actual correlation numbers to look at which neighborhoods most highly correlate. Now, we don't see a super strong trend here, which makes sense. We aren't seeing those huge separations in the density plot, because remember, our overall was that there isn't really that relationship when we have all those listings together. And we saw that there weren't that many neighborhoods with a really strong correlation. It is still between 0 and 0.5. So that kind of, makes sense in terms of the plots that we're seeing here. But picking out these plots can help us to see our data and the trends better, more accurately. And so this can also help you in your own analysis. If you were to see your own data not looking the way you expected, probing it in a different way can help to clarify why. Now we have kind of a better explanation of why we didn't see the trends we were expecting for parking, right? It's kind of neighborhood specific, and that we can kind of have that explanation now. There's a question about price of the Airbnb. So price is set by the owner, but the Airbnb advises you on a recommended price, because Airbnb takes a percentage of your profits as a renter. So they also want you to maximize your amount of money, because that maximizes the percentage that they get. And so they want to help you to recommend what's the highest price I can list this for and still have someone book my rental. So the price is, yes, set by the owner and advised by Airbnb. And so that's also why, it's important for us working for Airbnb for this case to figure out what variables affect price the most, and help them with price setting. As Airbnb is also very interested in what the accurate price should be. So the red and green areas here are parking versus no park. So red is no parking, and the distribution. So most of the values for this neighborhood, for the price, there's no parking, for around this price here. But really what a density plot is it's showing you, it's basically a probability. So unlike a histogram, so density plots get slightly more complicated because it's actually the area under the curve is basically the probability that you would find a value between X and Y. So between, let's say, the probability for getting a value between 0 and 100 is the area under this curve. So it's like the probability. So it's higher here, there's greater area. We have a higher probability of having no parking between these prices. Does that make so? A density plot is slightly more complicated than a histogram, but it's overall showing the same thing, that most of your values are around here. So density is kind of similar to frequency, a little more complicated because you have, it's a probability thing. But yeah. So does that make sense in terms of anyone who is confused about reading this? So what we're looking at here is, like I said before, if we had a really strong relationship, we might see that the peak for green, which is parking, would be over here in higher price, around 200 to 400 maybe. And if, then we would see our red peak over here, lower price. So, we do see this kind of this separation for some of these plots, these differences indicating different, probabilities for these values. Does that help? Okay. Yeah, and the negative prices. So yeah, that happens with just calculating your since this is calculation, it's not like a histogram. You are actually using kind of an algorithm to calculate this density plot. Like I said, it's like a probability for finding a value within that region. So it does calculate it and has that kind of that negative there. So you have a very low probability, but because it's probability, it gives you those negative numbers instead of a histogram, which gives you the actual values that are there and the frequency. Okay, so another thing that we can do is, so anyway, I just want to summarize the main takeaway, I guess, from this, which was that even if you see that overarching relationship and it doesn't quite make sense, breaking it down into its pieces, probing your data in another way can help you to see trends that you wouldn't have seen before. And so, this might be more revealing. Instead of making a density plot, if we had looked at the numbers for the correlations for each neighborhood, so you could see how they change based on neighborhood. But so another thing that we can do moving on is, but with the same trend of breaking down your data. So we also found before that price seemed to be correlated to the number of bedrooms or number of people that are accommodated. So we can kind of go in a little bit more detail there, right? We saw that kind of positive relationship, price increases as the number of bedrooms increases for that listing. But we wanted to know, how does price vary by property type? So what if we broke it down for a 1 bedroom and for 2 bedrooms for each property type? So, we can also make these box plots and to see how, to make that more granular data, that different exploration. We're looking here at price versus the type of rental for a 1 bedroom. All of these are 1 bedrooms. And then down below, this is for 2 bedrooms and the box plots. So we can see, let's go ahead and look at any differences you see, the variation. Do you notice any different trends, or is it helpful, I guess, in this case, to break it down by property type for 1 bedroom versus 2 bedrooms? In our previous data set for parking, we did notice that it was pretty helpful actually to discern which neighborhoods have that positive correlation. What do you see here? And again, this is for 1 bedrooms and 2 bedrooms. Yeah, these are great observations about the variation between these different things. That there are even just a different number here. We have more options for a 1 bedroom versus a 2 bedroom property. Yeah. Okay, so let's discuss for this for 2 bedroom versus 1 bedroom properties. So we do have pretty significant variation, honestly, for all of these. Um, we see a lot of variation for apartments, for condominiums, for these things that we can compare. We do see quite a bit of variation. And so, for this case, it's important to look at, but when I look at this, I don't think that this is quite as revealing as what we saw for parking with neighborhoods, where we could kind of make an inference about the trend to say, actually, that overarching relationship or lack of relationship that we saw for all data points was really because we weren't looking at each neighborhood in particular. Here, when we break it down by the property type, we do see a lot of variation. So this can help us to explain, like we talked about before, why we didn't see a super strong relationship in terms of the correlation number. And a question about the graph. Yes, I will cover why these points are separated. But here we don't really see particular trends. This could include, this shows some of that variation, the breakdown between 1 and 2 bedrooms. These points up here are the data points. They're the outlier data points. So they're spread out. I mean, here they're more clustered because there are a bunch of data points that all range between a little under 300 all the way up to 500. So we plot each individual outlier data point when it exceeds these upper and lower bounds. So this means that there was a data point where the price was about 425, maybe 450. There's a data point that was $500 for other. And here for a guest suite, there was a data point that was about $225, about $300. Does that make sense? So we're just plotting those outlier points. But anyway, so we are seeing quite a bit of variation, and this is important for us to note, and could be important if we saw, for example, that for 1 bedrooms, apartments, were not very expensive, but got super, super expensive for a 2 bedroom. We don't necessarily see a whole lot of that here in terms of comparisons. We would expect a 2 bedroom to be slightly more expensive. But yeah, so this is the same idea you should be thinking about in probing your data. We saw that initial trend of increasing bedrooms means increasing price, but when you break it down into property type, that can show you that variation. It can help you to find more trends. So that is something that's really important to do, to use the data that's given to you. Okay, so we have been, up until now, primarily interested in understanding what factors influence the price of an existing listing. So, one of the things that we were tasked with doing is finding out, so one of the things that we were tasked with doing is finding out things that are important or related to price of our listing for an Airbnb. So if we wanted to ask for our hypothesis, if you are Airbnb and you wanted to make a recommendation to a renter on how they could increase their price pretty easily, right? We can look at some of these other things. So let's say we have this variable, air conditioning, and then we have a TV, and looking at their correlations with price, right? Because these are variables that are pretty simple for a renter to incorporate and might be worthwhile if it actually made a difference in terms of the price. So what do we think? Do you believe that this would work? For someone to, to add air conditioning or a TV based off of the correlations with price. Like, would it be worthwhile, do you think, for someone to buy a $300 TV to increase their listing? Would that be a conclusion that you should make based off of this? Okay, everyone is doing great here, really thinking about what we've talked about, kind of our points through all of these cases so far, thinking about other variables, right? Not just relying on your data. Some people are saying it could be a marginal increase. People are saying it really depends on location for air conditioning. Absolutely, that's great. Also thinking about the size of your rental, yes, square feet per location. If you have a huge place, air conditioning might not be a small expense. That could be a huge thing. And is it really worth it? Yeah, these are excellent points. Yeah, depending on size, depending on the season, the climate of your location. Yeah, the TV, it's tough to know with that too. The TV seems to have a slightly higher correlation. So let's talk about that. So we have, you all have been doing a really great job kind of following this idea of, we won't just rely strictly on the numbers. So first observation, correlation is not super high here. We talked about this, and there were some helpful tables in the live chat about what we would call a strong positive relationship or a weak positive. So this is about 0.2 and 0.27. So that's not, they are positive relationships, but not super strong correlations. Which one thing that we learned from our lesson so far is that could mean that it's not a linear relationship, that there are other factors, or we need to break it down, or there could be other factors influencing this. So for example, with air conditioning, that was a great point that a couple of people made about air conditioning might be worthwhile if you are in a hot location. If you are in a place that would really benefit from air conditioning, this slightly positive correlation could really be made stronger if you're living in a place that is very warm, and you're renting to, if you're living somewhere, your rental is in a very warm location, someone might really benefit from air conditioning and you could really increase the price. If you're in some place very cold, maybe that wouldn't help. If you're sitting in the middle of Alaska, that's, air conditioning might not be worthwhile to add to your rental. So thinking about those other things, not just that adding air conditioning will automatically increase the price of your rental, are important. The same with a TV. So one thing that, that could be causing this correlation is that there might be a trend where more people or larger rentals have TVs automatically, and that is also responsible for this correlation with price, because we already know that bedrooms correlates pretty strongly with price. So it might also be that having that TV, those rentals most likely have TVs already. So it's not the rental itself, it's really that something else like size of the rental is more responsible for this positive correlation. But we do see it. And so there might be value in adding a TV to your rental if you can make more money from it with a pretty small investment up front. So the main point is, thinking about those other factors that could be influencing your correlation when making those types of decisions or making those types of recommendations to a company like Airbnb. Okay. Yeah, so there's a good question about if we had both of them, how would that affect the correlation? And yeah, so we would have to look at the relationship between places that have both air conditioning and a TV and how that relates to price. That's a good question. So we would have to do some separate analysis there. And yeah, these are great points. Really good, very creative thinking here about what could be responsible for these, and that's exactly what you have to be thinking about in your analysis. So one thing that we talked about was breaking down your data into other to look at it in more detail. One of the things that can be important, especially with a rental, if you're renting out to people, is how price changes over the year, over some span of time, because we know that there can be a lot of factors that time isn't just, or excuse me, price isn't just influenced by things like the number of bedrooms or having a TV or parking, etc. Not just those kind of concrete factors. There are also things that fluctuate over time, right? Price, we want to know, does price change over time? Because, right, we're making this recommendation for Airbnb on how they should advise, what are the relationships with price and how can this help renters to set the best price? So we need to know, does price change throughout the year? So if we look at our data from 2019, from July of 2019 to July of 2020, we can let's look at this plot, we have this trend. And then we can also look at a smaller interval. So here we're looking at the span of about a month. We're looking at July 9th, 2019 to August 5th, 2019. So this is over a month. We can look at this pattern. So when we're analyzing data like this, we can see, we can see two different trends. We can see seasonal trends and we can see trend effects. So seasonal trends or seasonal effects are periodic. So we have these changes that correspond to different seasons, basically, as it suggests, and trend effects where we can see whether it's the cyclical nature of our plot. So for our trend effects, that would be saying, I guess I will kind of explain. I'm going to kind of give away a little bit. But our trend effects would be that we have a cyclical nature, but we see an overall trend, right? Is it going up or is it going down overall, right? Outside of our like the up and down cyclical nature of our data. So with that being said, can we see any seasonal or trend components here? So when we look at these, what do you see for both our year graph, basically looking at our seasonal and our trend effects? And then do you see any of that for when we break it down for 1 month? Yeah, these are great. People going on vacation, weekend trends, absolutely. Christmas, yes. New Year's, yes, right on. So we can see here, overall, I'll give just a quick minute. I want to give everyone a chance um, before I talk about it. I see there are quite a few other people typing. So I'll give just a second to let people continue thinking about these effects. Okay, so let's discuss. It seemed like everyone in the live chat is on the same page here in terms of interpreting these graphs. So we can see that we see this cyclical component. So if we start here looking at each, basically at each week, we can see these peaks in price, which indicate weekends. A lot of you said weekends seem to be indicating a fluctuation here and might be responsible for that. So absolutely. If you are Airbnb, you should be recommending people price a bit higher on the weekend, right? They can get a higher price on the weekend for a stay. The same up here for, looking at seasonal trends over a whole year. We see these peaks around, December, January, where we see a huge peak in price for Christmas and New Year's. And then we overall are seeing an increasing trend, which might indicate something like inflation. We see this overall just general trend of increasing prices over time, regardless of the time of year. Okay. So another thing that we should take into account here is that we might see slightly greater spikes or dips in months that have maybe more Saturdays, thinking about the length of the month. Or thinking about when, so taking into account the different things, if we saw kind of an unusual dip or increase on a particular month, we might have to think about, well, how many Saturdays were in that month? Is that a shorter month, a longer month? When you're looking at sales, this is a good point down here, that if you were thinking about holidays, you might see a decrease on Labor Day when stores are closed, something like that. So it's also important to think about those months, thinking about why you might see dips or increases that are not automatically explained right off the bat. And then, so we kind of already answered this question. What is the enormous spike that you see in the chart? Is it real? And how would you describe what's going on? So let's just take a brief minute, because I think a lot of you pointed out this spike right here. So do you think, let's answer, do you think that this is real? Yeah, a lot of people saying so. So yeah, this is kind of Christmas, New Year's time of year. Yes. Okay, so yes, good answers here. That yes, this is most likely real, especially because the average price. So it's important to look at a couple of things. When you see your data spike, it's important to look at the context. So we see this spike in average price, but it's not huge. It didn't spike all the way up from 165 to 500. It wasn't something that would be kind of out of the norm. It went up about $10. So not a huge spike. So you can say pretty reliably, yeah, that's real. Even if it was bigger than that, you would still have to investigate your data a bit more, because like all of you said, this is kind of the Christmas, New Year's, it's a holiday time. A lot of people are on break, going on vacation, taking time off. So for this, we could say that, one thing that we could also look at is you should look at more years. If we saw that same spike every single year, that also would tell us that it's real. But yeah, and you would also have to incorporate that if you were going to build a model to predict then you would have to incorporate, what's most important there is, is using as much data as possible. When you can add, if you were to build a machine learning model or something, if you can add as much data as possible to give your model the best sense of those yearly changes, you'll have a more accurate model. But let's answer question 9.3. Can we guess the busiest season, excluding Christmas, from this chart? Okay, some people are saying no. Some people are saying summer. Okay, a lot of answers for summer or saying no. So, so I think that so a lot of you made some good assumptions here about, thinking about when are people traveling most and saying it could be summer. So it's actually, and I think that's kind of correct in terms of a guess. And then also saying that no, you can't necessarily decide the next busiest season because we're only looking at um, uh, 1 year. So, and we also see that there's this trend of increasing prices each year. So we don't see another kind of big spike like we did for Christmas. So we would definitely need to incorporate additional years to find to see if there are any other seasonal trends that really stick out to us. So one of the things that's important is to get other data sets as well. So, we found our first most popular, which was Christmas. We can definitely tell Airbnb, yes, Christmas time, there are higher prices. But one thing, if we wanted to explore deeper these trends that we're seeing, is to find other data sets, like a city close to New York City, right? So if we found similar trends in other places, in other cities around New York City, then that can help us to either to confirm the trends that we've seen, or to maybe try to explain them in other ways. The second data set we could look for is a city in the United States with very different weather from New York City. That could also have skew the pricing, or like we saw with air conditioning, explain some of those variables, those things that we saw. And then looking at cities very far away from New York City. So when we want to look at these different dates, when we wanted to do things about looking at seasons, when we want to start making larger conclusions about data, we shouldn't do it based off of just one city. There can be, like we've seen throughout this case and our previous one, other factors that can absolutely create those trends that might be slightly artificial, or influence, like in this case, New York City with parking was heavily influenced by the neighborhood that you're in. But that may not be the case, or that may not be the case with other cities. The same with location. So someone made a point in the live chat that in other cities, you might find that location, north, south, east, or west, is really correlated with price. So, these conclusions that we have here are from New York itself alone. They can't necessarily be extrapolated to every other city or everything else, especially worldwide for Airbnb. So let's discuss kind of our conclusions, our takeaways, and then we will take a break. Um, and yeah, some good points in the live chat about do most of the contributions come from US nationals or foreigners? So, definitely important data sets to try to find and to look at here in terms of what's contributing to these trends. Okay. So, so we saw that Airbnb prices are influenced by a few different factors. So we saw that location was a big one, not necessarily linear though, which was important to look at. The number of bedrooms, we investigated that a little bit more and found that yes, the number of bedrooms is positively correlated with price, but there were some caveats, right? We could kind of explain there's a huge variation there for one bedrooms. That's why we didn't see a really strong correlation. And also the number of guests. So the number of people that can be accommodated by your rental was also positively correlated with price. So we saw that like we discussed, some of these variables were pretty had a linear relationship and others didn't. We hypothesized that air conditioning might not be a linear relationship because there can be so many other factors like the location of your rental that can play in more heavily than just adding air conditioning itself. So it's important when you're doing your exploratory data analysis to look at distribution of your data, to look at those patterns, to to break it down into more detail to see how those patterns change when you look at more details of your data, and looking at these interaction effects, how certain variables can be responsible for the trends that you're seeing more than others. So all of these things should be taken into account, and I've been so impressed with all of you who've contributed in the live chat with really thinking outside of just the data that you see. So coming up with these explanations for not just taking the numbers on its face, but coming up with why do we think we could be seeing what we're seeing? And that is such an important skill to have when we are answering questions, when we're trying to interpret our charts, when we're trying to explain things that we, based off of our research, don't really make sense to us. So that is kind of the main concept here for EDA. So that wraps up our case. And I just wanted to see if we have any questions. Otherwise, we can, since you had a slightly shorter break before, we can take, I'll give it like two more minutes if anyone has any questions, and then we'll do a 20-minute break this time since you had a shorter break last time because I went over. We'll finish just slightly early. So, yeah, there are some questions about what you could do to predict things. So you will get into regression in the future. So things like a logistic regression might have been better for parking, to predict parking. You'll get into things that are better at predicting. There will also be machine learning models always get more, they are usually better at predicting non-linear things. You'll get into things like neural networks that you can not necessarily in this course, but I mean you can get into them in terms of digging online to find those things that will better predict non-linear associations. But yeah, for the sake of like this course and in the future, things like regression models will be really helpful to you. And that's when you can incorporate multiple variables. You can find out which variables are most responsible for your trends. But yeah, machine learning can also be just endless in terms of your prediction power. So yeah, correlation is pretty basic in terms of just finding those initial relationships. But once you find one you're interested in, I would say don't be deterred from going on your own and trying to develop those models. I've seen, personally, I worked with the DS Spray Empowerment cohort for their first 3 cohorts, and I have seen groups teach themselves machine learning models pretty, on the surface, but have been really impressive. So don't be afraid of trying to dig into some of those models after you start your EDA. So, okay, it is for you all 11:55. So we will come back at 12:15, I believe. So let's take a 20-minute break and yeah, we'll be back in 20 minutes.